Hello everyone and welcome to another lecture. Today we will be talking about inverse of a matrix. So let's say you have a matrix called M. It's a matrix and this is a square matrix. Let's say, alright, and we ask whether there exists some matrix called N such that if I multiply M with N, this gives me the identity matrix. Now there is a subtlety here, and the subtlety is that from our earlier discussions we saw matrix multiplication is not commutative. So in general we wouldn't be able to write Mn equals to Nm, right? So before we go on and clarify more about inverse matrices, we first have to talk about some cases that are called the left and the right inverse. So let's do that. Left inverse. So our matrix is M, and if we have some matrix N such that if it's multiplied from the left to M, this will give us the identity matrix. So this N is called the left inverse of M. Then similarly we can define the right inverse as, let's say the right inverse is now R, we denote it with R, and if you multiply R on the right side of M, you get the identity matrix. So this R is called the right inverse. Now a matrix M can have different left and right inverses, but if there exists such N equals to R such that Nm equals to Mr equals to the identity, then we can say this corresponds to some M inverse 1 such that M inverse equals to M inverse M equals to identity. This is our inverse matrix, this M inverse 1 inverse matrix, and this is the case that we will be interested in today's discussion. So how do you define an inverse matrix? Seems pretty easy that this M inverse 1 is the identity, right? This is the definition. But how do we compute it? How to compute? Well, we will talk about two approaches. Today we'll talk about one approach, and in the later lecture we'll talk about another approach. So today we want to talk about the approach where you denote the components of M inverse Ij in the following manner. Oops. And this M, let's denote it with M prime, is just the minor of the matrix M. Now in case you are confused by this formula, let's try to see an example and hopefully this will make sense. So let's erase it. So let's take a general 2 by 2 matrix first, because working with them is very easy. We want to calculate the inverse. Let's denote it with A, small a, B, C, D. You can see that the determinant of A is AD minus BC. And now we want to calculate the